Hey, hi everybody, Dr. Marty here, and today I'm going to be going over the notes for Chapter 1, which is a review. We only have one set of notes going over Chapter 1 because you've covered most of this stuff in 6th and 7th grade. Today we're going to talk about four things. The first is variables and how to use them to write expressions. The second is order of operations and how to apply them to simplify expressions and or equations. Third would be types of numbers. Those are rational and irrational real numbers. And then the last will be the distributive property. Okay? So first of all, what is a variable? Well, sometimes in algebra, we want to represent a quantity that we don't know or that could change possibly. And so a variable is a symbol that represents the values of a variable quantity. Okay? It's usually a letter. For example, you might see it written as x or y, or A or B. Now, any letter can work. You can also use a different symbol, but generally we use a letter. Okay? So that letter, if we see it in algebra in an expression or an equation or inequality, is going to represent something that could change, a quantity that could change. Okay? So sometimes we're asked to actually represent some kind of information that we're given using words algebraically or in an expression. So here's an example. How would you represent 3 less than half a number x? Okay. Well, I see two parts when I look at this. One of them is 3 less than, the other is half a number x. I'm going to start over here with half a number x. Okay. So the number or the variable is going to be x, right? So we're going to have an x, and we're looking for half of that. So we're going to multiply that by 1/2. We're going to end up with 1/2 x. Okay. Then there's a second part to this equation, to this expression, and that is it says 3 less than. 3 less than. Less than implies subtraction. We're taking 3 away from half a number x, so we're going to subtract 3. Okay? So if we wanted to represent 3 less than half a number x, algebraically, we'd have 1/2 x minus 3. Generally, certain words mean certain things. If you see less than, it's going to be subtraction. Greater than is going to be addition. Okay? And then quotient would mean division. Times obviously would be multiplication. And you might see something like 4 times a number, or a third of a number, in which case you would apply that as appropriate. Okay? Now let's look at order of operations. Order of operations. Okay? So order of operations, pretty simple, right? There are 4 steps. The first is to do the operations inside the grouping symbols, okay? Grouping symbols could be parentheses or brackets or any other type of grouping symbol. Second, we're going to simplify the powers or the exponents. Third, we're going to multiply and divide from left to right. And then fourth, we're going to add or subtract from left to right. Now, sometimes people use the term "please excuse my dear Aunt Sally," P meaning parentheses or brackets, grouping symbols, E meaning exponents, or for excuse. My dear, multiply, divide, Aunt Sally, add and subtract. Okay. Now let's actually go ahead and apply this. So here's an example. It says simplify 5 squared plus 3 times the quantity, notice the parentheses here, 5 minus 7 times 6, end of quantity, plus 16 divided by 8 times 4. Now, let's look at step 1. Step 1 is always to do the operations inside the grouping symbols first. So we need to look inside these grouping symbols. Those are the only ones. All right? So we're going to bring down 5 squared, right? And then we're going to have plus 3 times. Now, inside the grouping symbols, we want to apply the other steps in order. Do we have any exponents? I don't see any exponents inside the grouping symbols. Is there anything to multiply or divide? Well, 5 minus, this is adding subtraction, so we're not there, but we can multiply this, 7 times 6. So we're going to have 5 minus 7 times 6 is 42. We're going to carry on, plus 16 divided by 8 times 4. Okay, that was our first step. Now, do operations inside grouping symbols. We still have these grouping symbols. So, carry down 5 squared plus 3 times 5 minus 7 is negative 37 plus 16 divided by 8 times 4. All right? Now, even though we have that negative 37 in a grouping symbol, this is really just a multiplication. This is 3 times negative 37. So we're done with our grouping symbols. Let's look at simplifying powers. Are there any exponents? I see 1, and it's right here. So now I'm going to do that. 5 squared, 5 times 5 is 25. And then everything else is going to come down. Plus 3 times negative 37 plus 16 divided by 8 times 4. Right? Are there any other powers? No. So we've done everything inside the grouping symbols. We've done all of our exponents. Now we multiply and divide from left to right. Well, here we have addition. This is multiplication. So I'm going to do that one next. 25. 3 times negative 37 is negative 111. 3 times 7 is 21, so that's the 1, carry the 2. 3 times 3 is 9, 9 plus 2 is 11, negative 111. Plus 16 divided by 8 times 4. Still multiplying or dividing from left to right. Not multiplication here, that's subtraction. This is addition. Here's a division. 25 minus 111 plus 16 divided by 8 is 2 times 4. Still multiplying or dividing from left to right. Now we have 2 times 4. 25 minus 111 plus 8. All right, we're done with all of our grouping symbols. We're done with our exponents. We've multiplied and divided. Now we're going to add or subtract. We'll start here. 25 minus 111 is negative 86 plus 8. Now we can do our final operation, and we're left with negative 78 as our answer. So as you can see, we follow these 4 steps: symbols, grouping symbols, exponents, multiply, divide from left to right, add, subtract from left to right, and that will give us our answer. Okay, let's move on to types of numbers. Okay, so now I'm going to think about types of numbers, and we're talking about real numbers in algebra. We talk about real numbers. We'll get into potentially other types of numbers at some point in your future. But when we talk about real numbers, there's 2 types that we're focused on. The first are rational numbers. Okay? So a rational number is any number that you can write as a divided by b, where a and b are integers and b does not equal 0. Okay? It's very important that b does not equal 0 because the denominator of a fraction can never be 0. Okay? So this includes integers, fractions, and terminating and repeating decimals. So what are some examples? Well, integers, right? Integers could be 7, negative 48. Those are integers, okay? Fractions. Well, fractions, so you could have 6/5, right? You could have negative 18/7. Fractions, okay? And then lastly, it could be a terminating decimal. So that could be something like 0.6, negative 4.82. All right? Or a repeating decimal. Repeating decimal could be something like 3.3 repeating, 3.3333, or 2.45 repeating, 2.45454545. Those are decimals that repeat. So real numbers that are rational can be written as a over b, where b does not equal 0. They include integers like 7 and negative 47, fractions like 6/5 or negative 18/7, terminating decimals like 0.6 or negative 4.82, and repeating decimals where the decimal place repeats like 3.3 repeating or 2.45 repeating. Now, those vary from irrational numbers. An irrational number cannot be represented as the quotient of 2 integers. Okay, it cannot. This is going to include non-repeating decimals and things like square roots of all the positive integers that are not perfect squares. So we'll talk about that in a second. But so what's an example of a non-repeating decimal? Something like 5.78963245 right? These are not repeating, and this goes on, right? Or it could be negative 0.276981334 ... right? These are going on and on and on forever. They don't terminate, and there's no repeating pattern there. Okay? Number you might know, pi, right? Pi, ratio of the circumference of a circle to the radius, or I'm sorry, to the diameter. Obviously, that is a non-repeating, non-terminating decimal, 3.14159, et cetera, et cetera, et cetera. And then any square roots of positive integers that are not perfect squares. So, for example, if you took the square root of 4, you would get 2. And so that would be an integer, that would be a rational number. But if I did something like the square root of 7 or the square root of 13, those are not perfect squares, and their answers would actually be non-repeating, non-terminating decimals. Okay. Then finally, let's talk about the distributive property. Okay. So terms of the same variable and factor, the same variable factors are like terms. You can combine like terms and use the distributive property to simplify expressions. Okay. So our distributive property looks something like this. Here we have A times the quantity means it's in brackets or in parentheses, B plus C. Well, we can distribute this so it's A times B plus A times C, right? That gives us AB plus AC. Same thing here. A times the quantity, B minus C. We can get A times B times A minus C, or AB minus AC. Well, what does that look like in practice? Well, let's say we had 4 times the quantity, x plus 2. We can distribute, so we get 4 times x plus 4 times 2, all right, or 8. Here's another example. Here we have 6 times the quantity 3x minus 2y. We're going to get 6 times 3x, or 18x. We're going to get 6 times negative 2y, or negative 12y. 18x minus 12y. So that wraps up all of our notes for Chapter 1. This was a review. Most of this should be pretty simple, but I wanted to make sure you had it in your notebooks. So as we're going forward, you can reference it, and also it'll help you prepare for our end of the semester and end of the year finals. Hope you all have a wonderful day.